Okay guys, so we have our final problem of the section here. So let's take a look at it. Okay, and just kind of read through it with me as we go. So 9. F is the differentiable function, therefore I can take the derivative of it, whose graph is to the right, or aka below. The position at time t in seconds of a particle moving along a coordinate axis is, and now look at what they've given me. Okay, so the position is an integral of f of x. So immediately I need you to start thinking that means f of x is equal to the velocity. Because if I work up from the velocity, I'm going to get position. Okay, and this is the graph that we have over here. In other words, I'm looking at the velocity graph. So if you want to think about it that way, I'm looking at v of t. And it wants you to use the graph to answer the following questions. Well, okay. What's the particle's velocity at time t equals 3? This is the velocity graph. So v at 3 is equal to 0. And in fact, I think, yep, we can go ahead and put some values on there. It's 0 meters per second. That is v of t. B, is the acceleration of the particle at time t equals 3 positive or negative? Well, the acceleration is equal to v prime at t. So I need to look at what this graph is doing as far as increasing or decreasing. And since it's increasing at 3, the acceleration at 3 is definitely going to be greater than 0 because my slope at that point is positive. C wants to know what is the particle's position at time t equals 3? Well, position is defined up here. So if I want to find the position, this is part C, I want s at 3. And s at 3 is equal to the integral from 0 to 3 of f of x dx. So I want the area underneath this curve right here. Well, that's a triangle. It's 1/2 times 3 times 6. And because I'm going to the right and down, the position is going to be negative. So it's going to be at negative 9 meters, or at 9 meters to the, it doesn't say, coordinate axis. So just say negative 9 meters since I don't know if it's horizontal or vertical. Okay? D, when does the particle pass through the origin? Well, that's when the position will be equal to 0. So here's the thing. I start at the origin because it doesn't tell me I've started elsewhere. I move to the right, and I've moved to the left, 9 meters. Now I need to move back to the right that same 9 meters. So that means I'm looking for the place underneath this curve that matches the signed area that was underneath there. So if this piece here was 9, I want this piece here to be 9. And that gets me back to the origin. And so therefore the particle passes through the origin at t equals 6 seconds. E, approximately when is the acceleration equal to 0? Well, if this is the velocity graph, then the acceleration is equal to 0 wherever it has a 0 tangent. So that's going to be at t, whoops, I keep using t, it's x. At x equals 7 seconds, or we could say approximately equals 7 seconds because I have that 0 tangent. When is the particle moving toward the origin? Okay, well that means the particle could be moving either left or right, just dependent upon where it is in space. So if you want to think about what this is doing and get a good handle on it, let's say I'm starting at the origin, and then I move to the left 9, I'm not moving towards, but then at 3 seconds I stop and I start moving toward the origin again. So one of my intervals is from 3 to 6 seconds because I'm moving toward the origin. Then I pass the origin. Now I'm going to be moving still in the positive direction because I'm accumulating positive area, but I never turn back around. so I'm never moving back toward the origin the other way. So when I answer G, G is going to be from 0 to 3, and again from 3 to, and this is probably a bad graph because I have no idea if it's closed. So I'm just going to say 3 to infinity because at this point I'm not sure what happens to this piece, and it doesn't say it's closed. So we're going to improvise there. Okay, and then finally for H, the question asks, on which side of the origin does the particle lie at time t equals 9? Well, again, I've gone to the left of the origin when I have negative area, then I've gone back towards because I'm accumulating positive integrated area again, and then I'm continuing on, never to turn back. And so look again, this was a minimum. I was in a minimum position, and then I'm hopefully at my max position because I'm probably going to switch over. And so therefore I have to be to the right of the origin. Sorry, to the right of the origin. Okay, so I'll see you tomorrow in class. Good luck on your homework.